And number 5 was the surface area problem. And these, if I recall, looked pretty good. I think what got some people was there is a little bit of an algebra trick that hopefully you've caught on to. Some people have not. That that both arc length and surface area have the ds in it, and that ds has a square root. And so there's only a limited number of things we can really ask you to do that have an antiderivative. And this little algebra thing that comes up here, I want to emphasize this because it's one of those things that just as far as exercises go, you're going to see. So this was our function. And when we differentiate it, first of all, saw a few people using quotient rule, which you could do, but it's overkill. Because this is a constant, you can really just ignore it. You're really just taking the derivative of e to the y, which is e to the y, and the derivative of e to the negative y, which would be negative e to the negative y, and then multiply it by the constant 1/2. So no need to get into quotient rule. When you square that, so this is going to be kind of an algebra review here as we look at this. Remember, it's tempting to want to just square each piece individually. But remember, you really have to FOIL that out on top, right? That's a binomial. So when you FOIL it out, you'd have e to the y squared minus, when you multiply these together, you just get 1, right? Because it's e to the y, 1 over e to the y, and then there's a minus. So you have a minus 1, and then the other FOIL is another minus 1, so you have minus 2, and then plus e to the negative y squared all over 4. OK. And you could rewrite these. I like to, at this point, just rewrite this as e to the 2y. But you could leave it like that there. So now, whoops. So this was dx dy squared. Right, there was dx dy. Then we had to square. We're going to need the square of it. And we're going to need the square of it plus 1. Right? The formula has that derivative squared plus 1 in it. But notice what happens if I add 1 to this. This is all in fourths. So adding 1 would be 4/4. So this would go from being a negative 2/4 to a positive 2/4. And here's where this recurring algebra trick comes up for us. This may look like something kind of ugly, but notice that these two expressions are identical, except for the middle term is the opposite sign. What that tells me is that this should factor exactly like this, except for with a plus sign. Because that minus, the only thing that minus comes from is that minus in between. So when we added 1, it becomes a plus. So this, although maybe not obvious when you look at it, will factor as e to the y plus e to the negative y over 2 squared. So it's actually a perfect square. Now, I wouldn't necessarily expect you to look at that alone and say, hey, that's a perfect square. But because it came from this thing that we already know is a perfect square, because we just squared it. So this little thing where that middle term just changes sign, hopefully you kind of saw that reoccurring in the homework. If you didn't catch that, then you really can't move on to the integration on that one. So what else? OK, so when you finally get to integrate, a couple words about evaluating the exponential with the log. But we had a limit of log 2. So at the end, you end up with terms that look like, say, e to the 2y and e to the negative 2y, right? And you're evaluating these things at natural log of 2. So for example, e to the 2y is e to the 2 natural log 2. Now, most of you recognize that, OK, I should be able to cancel that because they're the same base. The problem is written like this, that 2, some of you were unsure what to do with that. So here's where you really want to express it like this, actually, back to this form. Because then what you're hoping to have is nothing in between there. So e to the natural log of 2 squared. Now that simplifies as just 2 squared, or 4. And then likewise, for e to the negative 2 natural log of 2, you want to do two things. You don't want that negative there. I guess you could bring the negative 2 up there, but I immediately, when I see negative exponents, put it on the bottom. So that would make it a positive, and I'm going to do this. And now again, those cancel each other off. 1 over 2 squared, or 4th. So just a little review about how those two interact with each other and how you have to have it expressed so that they perfectly cancel off there. Those were the biggies. I think most people had the setup good. It was recognizing this factoring. So be aware of this little trick. And then just this is more of an algebra thing, how these functions interplay. And this is a pretty common thing. We like to give limits of natural log when we have bases of e, just so we get nice results. So you should be comfortable with that manipulation there.